Guys, welcome to my YouTube channel. I hope you are fine. I hope this statistics playlist is fine. So in the last lecture we discussed about the frequency topic where we shared about what is frequency, what is relative frequency, what is cumulative frequency, and we also implemented this code in Python as well. So today in this lecture we will going to study one of the very important topics in the statistics and probability, that is measures of dispersion. This is very important topic. See, what is measures of dispersion? It is first and foremost, it is also called as the spread, also spread, measures of spread. So what does this mean? Measures of dispersion means how the data is spread around the center value. How the data is spread around the center value is what measures of dispersion will tell. So, what is the difference between measures of central tendency and measures of dispersion? Measures of central tendency will tell the exact center value of the data, but measures of dispersion will tell how is the data in the surrounding values of the center. This is what measures of dispersion says. So, understanding how the data varies around the center values is crucial in data science. Dispersion means it helps to detect the variabilities, outliers, and model real world and uncertainty effectives. So, what does this mean? This means that how the data is around the center is nothing but the measures of dispersion. It helps in finding out the outliers, finding out the range, finding out the interquartile range, helps in removing the outliers using the box plot, and all these things comes under measures of dispersion. And this we will cover in two lectures because this is one of the very important and very important concept for it. So the first we will study some of the dispersion measures. Okay, the first dispersion measure is the range. So what is range? Let's say in your data set you have some values. Let's say you take this particular data set only. So in this data set, what is the maximum value? This 24 is the maximum value, correct? So here I will take this, and I'll highlight this as maximum value. And what is the minimum value? This is the minimum value. So the difference between the maximum value and the minimum value is nothing but range. So to find the maximum value, minimum value, and then take the difference of it will give you the answer of range. So the difference between the highest and the lowest values in dataset is called as the range. But there is one small problem in this method. It is very sensitive to outliers. Sensitive to outliers. Sensitive to outliers. Now I will take one example to show this point. Let's say you are having this example only. Let's say you are having 10, 15, 20, 25, and in place of 30 we will take, let's say, 200 value. So now you see this value is the extreme value. This is not in this 10, 15, 20, 25, 30 range. It is the extreme value. Some random value it has came. So this particular value is an outlier. Okay. So now if you calculate the range here, you will see that if you minus 200 minus 10 here, what you are getting? You are getting 190. Means this range is getting affected by the outlier. So that's why we won't be using this range approach often, as because of if any outlier is present, it will destroy the entire prediction and observation. So that's why what we will do, instead of using the range, we will be using some other approaches. Okay, so now this range is useful only if your data doesn't have any outlier, then you use range. The second parameter, then the second measures of dispersion comes is the about the percentile. So what is the percentile? So in exams also, competitive exam also, you have heard the word as percentiles. So what is the meaning of 40 percentile? I will take example of 40 percentile and I will explain what is the meaning of 40 percentile. Now let's say here I will take my white color and I'll explain on this line. Okay, so let's say this is the data which is having the 5 points. 1, 2, 3, 4, 5 points we are having. Okay, let's say this value is 10, this value is 20, this value is 30, this value is 40, this value is 50. Correct. So obviously your median is what, 30 is your median because it's odd number and the centermost value is the median. So this median is also called as the 50 percentile value. 50 percentile. So what is the meaning of 50 percentile? The data from this 0 till 50 comes under this 50 percentile. Means this 50 percentile means what? 50 percentile of students are ahead in comparison to the previous data. Means what? Let's say in exam you got 50 percentile. 50 percentile means what? You are ahead of 50 percentile people in particular area. Then it is set to 50 percentile. Means you are getting 50, you are better than 50 percentile of people. Then it is said to be percentile. So percentile is the value behind the value below which a given percentage of data falls. Means the data, this particular data below 50 percentile is nothing but 50% is called as the percentile. The 40 percentile means what? 40 percentage of observations lie below that value. So that's what here what I told. 50 percentile means the records below this 50% value, below this particular 50 percentile value comes under this 50 percentile category. So now to calculate the percentile we have two approaches. One is exclusive approach, one is the inclusive approach. When we do coding, let's say we do this particular thing in numpy, let's say numpy python will use this inclusive approach, like numpy, stats module, pandas, python all uses this inclusive approach. For programs, we will be using this approach. But stats module you can use the, it uses the exclusive approach also. Generally for explanation purposes, to make calculations simpler, we will be using this exclusive approach. So what is this exclusive approach? What is the formula? What is this P all about? We'll discuss it now. So I will go to my I'll go to online. I'll go to my whiteboard. Online. Here I'll go to my free whiteboard. So now you want to understand what is the meaning of exclusive and inclusive. So let's say we'll discussing about the exclusive. Okay. So exclusive means you're having this formula, like right, to calculate the percentile, we will be using the value upon 100 into n plus 1. Now let's say here I want to use the 40 percentile. 40 percentile value. If I want to calculate the 40 percentile value, so what will my value get? You will get 40 by 100 into, now let's say here I am having the data set. Let's say I am having I will take 1 2 3 4 5 6 I am having. Okay, I'm having 6 as the point. So now what I will do here, I'll take 1 2 3 4 5 6. What is the n value? Total number of observations means 6. So you'll write 6 plus 1. So once you solve it, you will get the value as 40 by 100 into 7. So if you solve this, you will get 2.8 you will going to get. So 280 by 100 means 2.8. So what does this 2.8 means? Now you have to select the like 2.8 means what? This value is present between 2 and 3. Correct. 2 and 3 this value is present. So you will select 2 and 3. So when you select 2, it is called as floor value. When you select 3 means we are using the seal value. Okay. So now you are not getting right which point to choose. What is 40 percentile of this data? So to get the exact value of 40 percentile of data, we will be using this interpolation formula. So what is this interpolation formula? Interpolation formula. The interpolation formula is x of floor p. Okay, floor p plus, here you will get the value as what is this value? This value minus this, sorry, this percentile value. So p here I will write, so it should be p value. Okay, here we'll take p value, sorry, not p value, sorry, correct only, p value minus p of floor value, then you have to multiply it with this x seal value minus x of floor value. So what are these terms that this what is this x floor x seal? See here, what is this? What I told just now, this p value means 2.8 means 2 and 3 it is present. So if you check in this particular list, so what is this is your first value, this is your second value, this is your third value, this is your fourth value, this is your fifth, this is your sixth value. So what does this mean? This mean that this second and third value means 2.8 means second and third value, right? So what is your second value? This second value is 2 as per this data. Third value is what? 3. Third value is 3. So this x floor means 2 here. Why? Because this is the second value, this the value, this is the x means this is the p value, the lowest p value, the second value. Let's say if I keep this value as 20 30, then your xp will be 20 30, and here I'll keep the value as x floor as 20. So x seal means what? The uppermost value, the next value means the 30 value. 2.8 is closer to 3, so we'll call it a seal value. So this is how your x floor and x seal works. So what is your p value? P value you got is 2.8, correct? So what is the floor of p? If I say floor of p, it means 2.8 floor means what? The lowest value. So you'll take value as 2. So now you'll substitute all of these values. X floor means 20. What is this p value? P value you got as 2.8 minus what is this p floor value means what? 2 you got. So you got 2 into what is your x seal value? 30. So 30 minus 20. Now if you solve it, you will get the actual value, actual 40 percentile value. 20 plus zero point 0.8 into 10, which will you get the value as 28. So this is your original actual value you will get using the exclusive approach. This is the actual value, actual 40% value, actual 40 percentile value. If I keep this as 10, if I keep this as 40, if I keep this 50, if I keep this as 60 also, this value won't change. So now if I again erase this thing and I will write this example as 10, 20, 30, 40, 50 and 60. So you got this 20, this is the actual value you got. Okay, so this is the actual 40% value. But in programming, we won't be dealing with this actual value. Instead, we will be going to deal with the seal value of this particular interpolation. We will just do seal of interpolation. Interpolation. Seal of interpolation. When you do seal of interpolation means what will you get? You will get as 30 as the value. So this is how your exclusive approaches works. This is very good for the people who want to teach students or who want to make students understand how the calculations works. For theoretical concepts, this approach is very good approach, as this approach does not require any this approach is very good for teaching purposes, but Python does not work on this particular approach. So I will take one screenshot and I will explain you. I will take screenshot so that you guys can understand. If you see the notes, you yourself will understand what is the seal value, what is the floor value. So now you got this, you understood the seal value, right? So now what I will do, I will erase this entire thing again. So now I will tell you what is this second approach, that is inclusive approach. Inclusive approach. So this inclusive approach is mostly used by NumPy, Pandas, whatever library used, it uses this inclusive approach. By default, it uses inclusive approach. Why? Because it will give the correct value. Now I will take the same as the data value. What is the data value we took just now? 10. 10. Sorry, here I will erase it and I'll write 10. 10, 20, 30, 40, 50, 60 I wrote. Okay. So these are the six values that we wrote. So to calculate the percentile for this, so the percentile will be your n minus 1 into the percentile value by 100, and you will do plus 1. So this is how you can able to calculate this percentile using this formula. The advantage of this percentile is it will give the values that are present here itself. 10, 20, 30, 40, 50, 60 here, yeah, and you got 6, right? So here we will write n as 6. So now what you will do, you will solve this equation. So let's say I want for 40 percentile, so value I will keep it as 40. I'll keep it as 40. So now if I write 6 minus 1 into what value I have, I want to calculate it for 40. Okay, 40 by 100, and we'll write plus 1. So now what happened here, 5 into 40 by 100 plus 1, which is equal to 3. Means what, the third index value, the absolute third index value will be your percentile value percentile value percentile value. Okay, so now let's say here you are having 6 here. So now what is here, if you calculate 1, 2, 3, so this 3, what you got here is nothing but your, this is your percentile value. So this is how you got 30. Okay, so like this, the calculations of inclusive and exclusive works. And if you got p value in decimal, let's say 2.8, if you have got, you will directly take the value of CL and you will get 3. So like this inclusive approaches works. Let's say now if I take n is equal to 7 here, let's say, then what I will do, I will take 7 minus 1 into 40 by 100 plus 1. If I take, then what I'll get 6 into 40 by 100 plus 1, 40 by 100 plus 1. So you will get 2.4 plus 1, you got 3.4. So you will take the floor of 3, sorry, you will take the seal of 3.4, means you got the value as 4. So like this, the calculation of inclusive approach works. But this approach, what Python, what Pandas, what NumPy does, is not appropriate. Exclusive, that interpolation method is the appropriate way to calculate this. But for coding approaches, to for easy calculation part will be, since by default in libraries this formula is there, so we'll be using this particular approach. So I hope this concept of inclusive and exclusive is been clearer to you. So we will check the notes also. This exclusive is used in Excel and similar tools, but inclusive we use for NumPy, statistics. Python uses this particular approach. Now in this, if you want to calculate the interpolation, you will be using this particular approach. Here this is nothing but your floor value. This above one is nothing but the seal value. Here seal value of x. This is floor value. Floor here. This is your floor here. Floor here. This is nothing but the floor of p that we got here. So now we calculated this particular, let's say if you want to calculate p40 from this example with n is equal to 7. So by using exclusive approach, like you got, if you calculate all of this, 7 minus 1 means what, 6. 6 into 40 by 100 means 2.4 you got, sorry, 6 into in inclusive approach, if you try to solve it, sorry, in exclusive approach, if you try to solve it, you will get as 40 by 100 into 8 you got, n plus 1 means 8 you got. So means what you got, 3.2 you got. So when you try to solve by using this interpolation formula, means here either 3, either 4 you will get, like the third or the fourth value you will get. When you solve this particular thing, third value is what here, 18 here, fourth value is what, 21 here. So if you want to get the actual value, you will be using this exclusive approach. In inclusive approach, what will happen, 7 minus 1 into what is the 40 by 100 plus 1 you will get. So 6 into 40 by 100 means what, 2.4 plus 1, How much you got? 3.4. So this 3.4 means what? If you apply interpolation in inclusive also, you'll get 19.2. So like this, your interpolation will give you the exact value, and rank will give you the exact position, like fourth value. Rank will give you the 21 as the value. So now in the next lecture, we will going to discuss about the quartiles, as quartile is very important part. So I hope you understood this lecture. So please do like, share and subscribe guys, as it will help me in motivation. And the next lecture we will do outliers, very important topic. Then variance and standard deviation we'll do, and then we'll do the coding part. So that's it guys. Please do like, share and subscribe guys.